Hey, how's it going? Today I'm going to go over a problem on Leetcode that is apparently the daily question. So it's apply operations to an array. You're given a zero indexed array. Oh yeah, so then I'm going to treat this like I was asked this during an interview, and yeah, we'll go from there. Alright, so I'm given a zero indexed array, nums of size n, okay, consisting of non-negative numbers. You need to apply n minus 1 operations to this array, where the ith operation, zero index, you apply the following on the ith element of nums. Okay, so if nums I is equal to the I plus 1, then multiply nums I by 2 and set this one to 0. Otherwise you skip this operation. Okay, but after performing all operations, shift all the zeros to the end of the array. So return. Okay, it says n minus 1 operations to this array. So if we have an array of size, okay, let's look at this one. Oh my goodness. If we're looking at this array, do the following operations on I equals 0. So there are 1, 2, 3, 4, 5, 6 numbers in this array. And then we do nums I is equal to I plus 1. Then I multiply it, but it isn't. So I'll skip that first one. But since this case it's equal, then I do 4 here. And then we'll have a 0 afterwards, correct? Okay, yeah. And so on. We keep going until we have a match. So that must be what it means by doing n minus 1s, because we're going to be doing, if there's 6 numbers, we're going to do 5 operations. Okay, what else? So do I only need to do this once? I just iterate through the entire array, and then afterwards I'm going to move everything, seems like. Okay, yeah, and then we return in a new array that contains all of those values. Alrighty, so I guess in this case, what I would want to do is I would just do an iteration of I starting from 0, iterate until we do until n minus 1, and then for each case that we meet, we'll find the numbers, and then we can do another pass to determine where the numbers will be shifted around. I guess the options are, do we care more for like in place, or do we want to use another data structure? Because if I use another data structure, I could create like a new array, but that would happen whenever I find values that we can skip. But I feel like for this simplicity, it makes sense to just go through it once and then do it again, or go iterate through the same array. So why don't we do that? All right, so let's do for let I is equal to 0, I is less than nums.length minus 1, I plus plus, and then if nums I is equal to nums I plus 1, right? Yeah, I plus 1. That means nums I, we're going to multiply it by 2. And then nums I plus 1 will be equal to 0, right? Because every time we find the case where it matches, the one increment is going to be 0. And then what could we do? So if we have a 0, can we increment I an extra time because we want to skip it? We could, because say we're dealing with this case here where we do 2, 2, we're going to change that, and then now we'll be on this 0. But say for some reason this is also a 0, I mean, we wouldn't care for it. So yeah, I guess here we could actually do a I++, just to save us some time. And I mean, this is optional. It's not a big deal. Maybe we might even have to take it out if I overlook the logic. So then after I do all of this, we'll have a new, within our array, it will be updated. So then now, we would have to do another loop where let's see, we can let I equal 0, I is less than nums.length, I++. And if we find a case where nums I is equal to 0, then we want to remove that from our array and push it to the end. But then we need to make sure that we're not just continually doing this, right? Well, actually, no, it doesn't matter, because for each iteration, we'll just keep going. Because I will be, if I find the 0, I'm going to remove it. Remove it, push it to the end. And then say I have a 2 here. But say there's another 0 that I would have to handle. So there's that one edge case that could mess things up. So we could do like a an iteration where, let's see, can we do this in place without having all those complex logics? 0, going to push this to the end. I can't check for both because there could be a number at the end of it. So what I could do here is we will have 2 pointers, one to indicate where the start is, and then another one to swap. So that way, say we have a final 1, 4, the pointers will be incremented, and then we can have a pointer for pointing at the end. So if this equals a 0, this equals, okay, yeah, that makes it so much more complicated, honestly. I think in this case, let's actually just create a new array. So res will equal a new array, and then if this is not equal to 0, we'll do res.push. Push nums I. So that way we'll just add all the numbers, and then afterwards we're just going to append the number of the number of characters that we need. So while res.length is less than nums.length, res.push zeros. Yeah, I think that should work if I didn't mess it up. Oh, output is undefined. Whoops, I did not return. Return res. And let's see. Let's just see if it works first. Cool, so that works. And looks like it passed. Yeah, so in this case I have two loops, well, three loops. One of them goes through half of the first, actually no, this one goes through the entire array. And this one's just to append the rest of the zeros. So in a way this is not as efficient. Let's see if we can optimize it somehow. So if what I could have done here actually, I probably could have had, since I didn't want, I tried to do everything in place, but I feel like there were just too many cases I would have to handle and it made it pretty complicated. So instead of doing this right here, I can actually do all of this within my array, right? So these cases will do res.push nums I, and if we don't, so this will handle, like, if we don't do anything to it, we'll just push it into our result array. If we do update it, then we just push it. And this would need to be if nums I is not equal to 0. Give me a second. Let me think about this. So yeah, so I update the one in front of it, so we're good there. And then anytime I find a number where I have to multiply by 2, I do. And if I don't have to multiply, I will push it as long as it's not a 0. And then afterwards, yeah, I need to append the rest of the zeros, so that should work. Or not. What am I missing here? So I missed the 4 and the 2. Oh, whoops. I increment I here, so that messes it up. Forgot about that, sorry. Still getting an incorrect case. So if input is 0 and 1, oh yeah, I'm missing the very last number. So I can do an iteration where this one can go all the way through. And then if nums I is equal to that, but if I is equal to start length minus 1, so we want to make sure it's not the very last index. Well, nums not equal to, yeah, I is not, well, I is less than, and then yeah, so then we'll have this last conditional where if the last number isn't a 0, then we can push it, but if it is, or if it isn't a 0, yeah, we can push it, but if it is, then we won't push it. And then we append the rest of the zeros. So yeah, that's how I would further optimize that. I hope that all makes sense. Oh yeah, and then for time complexity, if we go through it, we have this initial for loop. These operations are all constant time, I believe. Yes, so we have one for loop that's order n. And then we have another for loop that could potentially be order n as well in the worst case. But yeah, I mean, that still evaluates the linear time. And then Space-wise, it's also linear. We're reconstructing a new array, and that should do it. Yeah, if you have any questions, feel free to leave a comment. If you like the video, you can show you that with the things you can do on YouTube. And yeah, thanks for watching. Bye.